Hi, this is Mr. Coon. We're going to tackle a few kinematics problems, in particular four um, types of kinematics problems, motion problems, that have some intuitive things about them, but you've got to think about them a little bit. So this first one, let's have a look. These types of problems are freefall problems. So the general convention in freefall problems all the time. So when you talk about coordinate system, the general convention in any of these, free falling, when the motion, because remember vector quantities, you need not only your magnitude, you also need direction. So with most of these, the general convention, the motion, any positive motion is going to be in the upwards direction. Okay, so let's have a look at this problem. Redbull cliff divers, they dive from heights of 28 meters. In most of these, especially falling and free fall problems, you can't take air resistance into account, because air resistance will significantly slow down the descent of any free falling objects, especially at really great heights. They'll actually get to a point where they'll get this velocity called terminal velocity, and they won't go any faster than that. But so we've got to assume that air resistance is negligible. How long would it take for the cliff diver to hit the water, and how fast would he be going? So we know that any positive motion is up. So let's have a look at some of our data. When you're talking about any free fall, there's a few bits of data that are pretty, if you think about them, if you just think about them logically, they should make sense. So first one is, how fast would he actually be going before the free fall? If he just does a drop, so here's our Red Bull dive right there. The height is 28 meters until he hits the water. And pretty logically, if he just does a straight drop without any acrobatics or anything, just a straight drop, logically his initial velocity is going to be 0 meters per second. That's logically. So he's going to reach some sort of final velocity, and it's going to take him time to do it. The other logical thing that we have also is our acceleration. Acceleration, when you're talking about upwards and up and down motion, you're going to have the acceleration due to gravity, and that is going to be fairly constant. It's going to be very constant at the sort of heights that you'll deal with, and it's 9.8 meters per second per second. Okay, now notice here, remember, because our positive motion, any sort of positive motion, is going to be in the upwards direction. That's why the pull of gravity, because of the gravity on Earth, the pull is always down towards the Earth. So any our acceleration is always going to be a constant negative acceleration. Very good. So in this particular problem, the first one, we want to find out our time, so how long it actually takes, and let's put that in purple. We want to find out our time. Okay, we don't know our time, and we want to also find out our final velocity. So final velocity we'll put in orange. The final velocity we want to find out. There's one more bit of information that I forgot to tell you. That is also in the question itself, is our displacement. Our displacement is 28 meters. Easy. So now we're going to decide which kind of equation we're going to use. First, we need to find our time. So without thinking about velocity for now, if we use these three bits of data, if we use the equation S equals ut plus half at squared, if we use that, we can actually solve for t. We can find out how long it actually takes for him to come down. Now here is also a couple of logical things. We know that logically, if his initial velocity is 0 meters per second, now I won't put in the units just so we save some space, multiply that by t. Anytime you multiply anything by 0 is going to be 0. So this particular first term is always going to be 0. And then here it's plus half of at squared. Now we know that acceleration is 9.8, so we can already put a minus there. So it's always going to be taking away velocity. It's always going to be accelerating in the downwards direction, always, never in the upwards direction. Okay, so we can already put that minus there. Half of 9.8 is 4.9, so that you can already commit to memory because you probably see that a lot. So I don't know if my 9 looks a little bit strange, but getting used to this pen, by t squared. Okay, so it actually ends up being the displacement, and I can already chuck that in. Let's put the displacement in red. The displacement 28 equals 0 minus 4.9 t squared. Okay, very good. Now, the other intuitive bit of information here that actually I didn't quite put in correctly, because the motion, and let me erase this actually, because the motion is in the downwards direction, so you are displacing yourself in the downwards direction. So here, your displacement is going to be negative 28 meters. It's going to be in the downwards direction. So here, it needs to be negative. Now that negative will become significant in a couple of seconds. All right, so to solve for t, if we put t on t squared even, let's put t squared on this side. So to get t squared on the left-hand side, we have to divide negative 28 by negative 4.9. So whenever you're dividing a negative value by negative value, these two cancel out. So it's just 28. So let's have a look. It's going to be, let me get Mr. Coombs' calculator, 28 divided by 4.9, and we should get 5.7. So t squared is going to be 5.71 seconds. Okay, which is t squared, so t will just be square root of 5.71, which will equal, let's have a look, square root button. Our answer is going to be 2.39 seconds. Very easy. Now the next part of the question is we want to find out how fast the person is going to be going. That one's quite easy because we've already got a really easy equation. We found out time, how long it takes for him to actually reach the bottom. So our next equation is going to be v, because we want to find out the final velocity equals initial velocity plus the acceleration multiplied by the time. Okay, which is very logical. The final velocity, because remember, acceleration is just a change of velocity over time. So that's what it's describing. So it's going to be adding on to how fast he was already going from the start, and then how fast it goes according to time. And we know that u is 0, so it's just going to be negative 9.8 meters per second multiplied by how long it actually takes to get down to the bottom, which is 2.39 seconds. 2.39 seconds. And that'll be 23. So it'll end up being negative. And this one, I hope that this second part is also makes sense. So it's going to be negative 23.43 meters per second. So it'll be negative. So this negative, because of our coordinate system, remember that positive motion is in the opposite direction. So a negative velocity just means as a velocity in the downward direction. We can see that here. So in my next video, I'm going to be talking about a different type of one-directional motion. And hopefully for now, this is going to be helpful, and I'll see you for the next video.